Hi, hello everyone. Thank you for coming. Uh, okay. 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 Anyway, like I said, this week we're going into DevOps and cloud. And then for week 7, week 8, we'll do ML and data science. And of course, we have a bag of free candy here. So if you like candy, always feel free to grab some. Okay. And here's a quick note following along. As with all the demos we've used AWS. So that means that if you have an AWS account, it'll greatly help you with our demos. All right, so we'll be covering today containers and Docker, and then everything that you see here. I'll be going over Docker and explaining what Elastic Beanstalk is, AWS Elastic Beanstalk that is, and yeah, let's just get started. So, Docker helps us with containers. Who here knows what a container is or has heard of what a container is? No clue what a container is. Okay, that's fine. So let's say that Satya has this great, wonderful, heavy React app. And Satya wants to get this React app to Caitlin on the right there. But unfortunately, there's a nice cliff in the middle. So, Satya cannot give Caitlin this React app because it's too heavy. But he's gonna try. So he's gonna try. Oh, also poor Caitlin, unfortunately, she doesn't know what NPM is, she doesn't know React is, she doesn't know terminal. So she cannot run this React app even if it gets to her. So we're gonna try. Satya's gonna move over. Great, and then oh no, she like falls off the cliff. So sad. It's so bad. So let's try it again. So that was without any sort of containers, right? You had this huge heavy React app, but then you want to kind of deploy, you want to try and make it available to everyone. So that's the entire motivation behind containers. So let's say Satya has this huge React app again, and we're gonna actually containerize it. Wow, it's now in a little container. Kind of hard to see. It's a gray box. And it's what we call a Docker container. We're using Docker specifically, so it'll be a Docker container. And all Satya needs to do is chuck this container over to Caitlin, and so she'll have it in the end. So if we see this, we're gonna chuck it all the way over, and now Caitlin has it. And so Caitlin can now run this huge, heavy React app on her own machine without having to worry about NPM or React or terminal or any of those. So what is a container? More formal definition. First of all, actually, yeah, it's those snapwares. That's a container that we're talking about here. It's essentially just a fancy computer science box, right? More specifically, it's a package of code that includes dependencies, so the application can run quickly and also reliably regardless of the computing environment. So AKA, if I'm able to containerize something, you're able to run it, you're able to run it, you're able to run it as well. Without the need to have a specific operating system or a specific environment variables, for example. Like I mentioned, this includes the code, any runtime environment, system tools, system libraries, and also settings. It's all packaged neatly in this one little box that you can use. And so you might have heard of something that does similar tasks, which is a virtual machine. But I'm going to compare and contrast containers and virtual machines here real quick, just to kind of motivate why we use containers. Here we have a description for a container. A container is the abstraction at the app layer, packages a lot of code and dependencies together. And you can actually have multiple containers on the same machine, and it's much more space efficient. It's really, really lightweight. So if you think of this little diagram here, we have the actual infrastructure. So think of this as like your buses and all your chips and everything. You have a host operating system that runs on top of that. And then you have something called Docker, And Docker can have multiple apps all attached to it. And these are all containerized applications. So they're running separately of each other on top of Docker, essentially. So Docker is able to run those apps at the same time, but without the need for any other operating system to run here. On the opposite side, we have the description for what a virtual machine is. A virtual machine is the abstraction at the physical hardware level. There's the need for more hardware called a hypervisor that allows multiple VMs on a single machine, and it's much more heavyweight. So you can see on the right side, you have the virtual machine with 3 apps, 1 app per VM, and every single virtual machine has its own operating system. Whereas on this side, there's no operating system per container. So you can think of a container as a much more lightweight version of what a VM can do. That's why we use. That's why people like to use containers. And yeah, we'll actually go into using our own container here in a bit. So I mentioned Docker. Well, what is Docker? It's such a nice logo, first of all. Like, what kind of computer software has a cute little whale as its logo? Like, you've never seen that, right? It's pretty cool. It's like a cute little whale with a whole bunch of containers on top, because containerization. Anyway, Docker essentially is a tool that helps developers deploy their applications via these things called containers to run on a host operating system. So like my example before, if I were to containerize an app and chuck it over to Caitlin, Caitlin can run it on her computer. And it allows users to essentially package an application with dependencies into like a cute little box, like I mentioned, and have it run properly. So that's what Docker is. It's essentially just software that helps us do this all. So without further ado, let's actually get into running a Docker container. So some prerequisites that you need. First is an AWS account, which will come in handy later, but then also a Docker Hub account, which you just look up Docker Hub, make one. And you also want to download Docker Desktop, depending on the operating system that you have as well. And then for our purposes, we would like an app, because we're going to try and deploy that. But essentially, Docker Hub, which essentially Docker Hub, you can think of it as like GitHub, which holds a lot of repositories. Docker Hub holds a lot of images. And Docker Desktop, you'll need it to run these commands. Okay, so let's go into a Docker demo really quickly. Okay, so let's say I have I just open up a new terminal here, and I already have Docker installed. So the first thing that I'm going to do is I'm going to run Docker run hello world. So that's like the little welcome message that they have. Docker run hello -world. It's already running at the other one. 1 sec. There we go. Docker run hello world. Not running. 1 sec. If you get this error that's saying this error may indicate that Docker daemon is not running, you need to actually start Docker Desktop, which is here, starting the Docker engine. If you don't do that, obviously it's not going to work, as I run into right now. But in a little bit, it should start up for me, and I should be able to run any Docker commands that I want. Any second. Great. Okay, so now I can put that away for now. And now I can run Docker run hello world. Hopefully, there it is. So this is the blank states like hello world message from Docker. It essentially just says hello from Docker. This message shows that your installation appears to be working correctly. Hooray, good job. And it tells you essentially what has been done in order to display all of this. So the Docker client, which is basically your Docker desktop here, contacted the Docker daemon. And then it was able to pull the hello world image from Docker Hub. So Docker Hub, like I said, was basically like the storage for a whole bunch of images. So any containers that you make, you'll basically be able to push an image of that to Docker Hub. So essentially what this did, it pulled the hello world image. It created a new container for that image on your local device. and then run the executable that's actually inside that image. So I went to like a cloud, wrote it down, copied it to your local machine, and then ran what was inside. And what was inside happened to be the output of all this text. Any questions? Cool. So that's pretty cool. We can now go into another example though. If we try and do something a bit more. So let's say, let's try and pull another image called BusyBox, and let's see what that does. So let's do Docker pull and BusyBox. And so it's going to pull the BusyBox image from Docker Hub, and it says that, oh look, I have it all here. Download a new image for BusyBox list. And if you ever get confused as to how many images you have on your device, you can just do Docker images, and it'll tell you how many you have here. Obviously, we've worked with many more to get this demo going. But if you've only done Hello World and BusyBox, you should only see Hello World and BusyBox. Cool. And so the next step that we're going to do is we're actually going to try and run some things on it. So let's just do Docker run BusyBox, and we're going to see what that outputs. So if I say Docker run BusyBox, nothing is printed out. Does that mean it did not work? False.
You have AirPods by chance?
I do have AirPods. Yeah. So Docker run BusyBox, nothing is printed out. That's actually as expected, because what BusyBox does is it takes in an extra command that you want it to do. So actually, I'm going to write Docker run BusyBox, but I'm going to say I want it to echo ACM hack. And so it's going to run this BusyBox container that is now on your machine with this command, which is echoing. And if you don't know what echo does, it essentially just repeats exactly what you said it. And voila, ACM hack. So pretty cool, right? I didn't even touch I don't know what BusyBox is. I've never touched any code for BusyBox, but I know that someone else out there has created this code and that I'm now free to use it. That's essentially the benefits of using Docker and containerizing. And notice how I can do all of this within my terminal, right? I don't need to like create any extravagant app in order to do this. All I need to do is have a connection to the Docker daemon and then able to pull those images and run it here. Questions? Great. Okay. So notice how we had a lot of containers, right? We can list them all, and we can also remove any of them if necessary. So let's go ahead and do that here. So I hope you clear up some space. So if I write Docker and I do ps-a, that will list all of my containers here. And notice how, oh, nice. Amazing. Okay. All right. Notice how it has names of my images, the commands that were created, when it was created, and some status. So notice how all of mine here have status exit. If they've exited, I'm basically no longer using them. So I want to actually just get rid of them. So what I'm going to do is I'm going to do Docker container prune. And I'm going to remove all stopped containers. You're welcome. I saved you 48.44 megabytes of essentially space. And so if I do Docker ps-a, I can see that there's no more because I've cleared them all. So we're just saving space here. Okay, cool. So that's pretty cool, right? We saw that we were able to kind of take an image that someone else had created, pull it down, create a container for it, and then run what was in that container on my local machine, which is pretty cool. And I didn't have to touch any of the code that's BusyBox or Hello World came with. That's cool and all, but let's actually try and containerize our own app, right? Docker is great and all, but let's you guys watch The Office. He's containerizing. I'm pretty sure what is that one, but I don't know. Okay, so so here's some few things. The prerequisite is that you have an app, right? you have your own app here. I'll actually run through this. I hope it is. Is it? It's not here. Other one. Great. Okay. So I have this app open here. I'm going to zoom in a bit. Okay. I have this lovely app open. There's a few changes that we need to make. Namely, you need to add a Docker ignore file, a Docker file, and then a Docker run AWS JSON file. And we'll go through what each one of those means. But the first one that we're going to go through is going to be our Docker ignore file. So the Docker ignore file essentially is just what you tell Docker to not package in your container. So for example, we don't want any environment variables in node modules, and we don't want a subfolder called build, which will come in handy. So we just add that here, and yeah, Docker will ignore it and will not package it. The next thing, arguably the most important one, is to go through our Docker file. So this is the most important thing that Docker uses. And so you can see that we'll have configurations, we'll have builds, and we'll have runs. So the configuration is essentially just we're using Node, and we're going to set the working directory within that container to /app. Then we're going to copy all the app files, so everything in here, to that container. And then we're going to run npm install. This is CI, is just npm install, but making sure that we have the exact versions in the log file as specified. And then finally, to run our actual container, we're going to run npm start, as we always do. So that is our Docker file. Let me go back to the slides here real quick. And the next thing that we want to do, as I mentioned here, is adding the Docker file. It's a bit different, but I'll update these slides in a bit. So essentially, you're adding your configurations, adding your build commands, and adding your run commands. And once we've had that, we can actually build the image. So I'm going to build the image here using Docker. So VS Code has this nice terminal that we're going to do. So Docker build, it's going to do Docker build, and then now I'm going to give my Docker Hub username / the name that I want it to be. So I'm going to do my username, and I'm going to give it a name as well as a dot to specify everything in my current directory. Right. Build. Oh, I forgot to give it a -t. Sorry. -tag. There it is. Okay, so as it's building, it's basically seeing what I have in my Docker file, and then it's going to run everything. You can ignore those. As long as it works, it works. So, yeah. And the next step that we're going to do as that is running is we're going to actually go ahead and try and run it after it's done. So we're going to try and run this app using Docker run, give it a port and the image that I have. So I'm going to run the exact image that I just created. Notice how there's 2 port numbers. The one on the left is where the app is exposed, aka localhost 3000, and the right port is the port used by the server inside the container. So for simplicity's sake, I just created it and I made it the same. You can choose any port that you want. Typically, a nice default is 80 for the exposed port. But let's hope that this is done. Great. Now I'm going to use Docker run, give it a port. I'm going to say 3000, 3000. And I'm going to run exactly what I just created. Notice how it's running React script start. And if I actually navigate over to localhost 3000, I see that I have a beautiful running web app. Yeah, and that's why it was called Hack Propaganda. I simply took the React app and I duplicated some hack logos and I changed the background so that it transitions colors. But yeah, and to prove that I'm not cheating, and this, I'm actually running a Docker container, I have no other instance of my terminal open. I'm not running I'm not running npm start on anything here. This is not running. There's nothing here, and the only thing that I'm running is my Docker container. So that's pretty cool, right? I'm able to actually run the container that I've just created on my local machine. So let's stop this now to save some resources. Control C, Control Z. I guess I'm not stopping it. That's fine. Moving on. Okay. Bye. All right. So that was me running it. Any questions so far? Cool. So now we get into the AWS portion, which is how are we able to kind of deploy this to the cloud, right? So that everyone can access this, even you can access what I just created. Essentially, it takes the Docker container, moves it, and AWS Elastic Beanstalk is able to host it, and so anyone in the world can go to that URL and find it. So we're going to deploy the container with the help of AWS Elastic Beanstalk. That's their logo. That's the live version of their logo. So what is AWS Elastic Beanstalk? Well, it is essentially a platform as a service that's offered by AWS, which is the suite of technologies that we're using, the suite of services that we're using. It's much like Heroku or Google App Engine if you've used any of those in the past, really similar. And it actually supports running single container Docker deployments, which is great, perfect for us, since we only have a single container that we want to deploy. And essentially, as I mentioned, it hosts a Docker image so that anyone in the world can find it. So let's go through a quick demo here. So first, you must log in, and then you will publish your image. So if you haven't logged in through Docker desktop, then you would log in your Docker desktop. Otherwise, you would type in Docker login on the terminal, and it'll log in for you, or you enter your credentials, log in for you, and we'll push the image. So let's actually see that here. Okay, I'm just gonna bye. All right, so I'm going to run Docker push, and I'm going to push propaganda. I'm going to push the image that I just created using this command, and it'll okay, let me try this again. Oh, it's because it's mine. But do you have yours?
Yeah, it's just so my first SATYN SUB and then slash. I think I need to have to demo or something.
Let's hope. Great. Okay. So the reason that didn't work is because it's not my laptop. I log in, try to push to my what is it? My hub, but obviously I'm not signed in. Okay. So we have a nice push here. Sounds great. Looks good to me. And so now that we publish this image, we can actually create the next most important file, which is a Docker run.aws JSON file. So we just essentially have these that's inside the Docker run aws.json file. The most important thing is to have a container port that matches the same port that you expose, and also the name of your image to exactly what you did. Everything else is pretty much optional. If you don't have host port, it defaults to container port. And logging, you don't have to log errors, right? And update is an optional as well. So those are the most important things to have. So this is already created, this is already pushed. So all we need to do is kind of move on with our demo here. So now we navigate to AWS Beanstalk, and we work with the lovely technology that is Amazon AWS. Okay. So I'm going to navigate to Elastic Beanstalk. I'm going to create an application. I'm going to select a web server environment. I'm going to give it a name. I'm going to say Hack Propaganda, as I have been. I'm going to give it the domain. Let's see. I love ACM Hack. Let's hope it's not taken. Darn it, I took it. We love ACM Hack. Let's see. Nice. Okay. So we have that. And then the platform that we're going to choose Docker. And this is where we're going to upload our application code. The only thing that you need to upload is that docker.aws.json file. So I'm going to give it a version label, let's say 1.0.0. That's just going to be a local file. I'm going to choose that file. Great. It is going to be this one. I'm going to open it. It should run. And I'm going to click next. And I'm going to give it the role. The top one. Okay, cool. So that role. So sometimes we'll go over these role setups, but essentially that is what it is. And then I'm going to skip to review. And scroll all the way down and submit. And hopefully, if everything works, it'll be up and running in about 5 minutes. But anyway, as that is running and as that hopefully works, that's essentially all that you need to do. And we've essentially been able to containerize an app, our own app actually, with Docker, and then deploy it to the world of AWS Elastic Beanstalk. The one thing you need to remember to do is actually turn on your environment when you're done. Yeah. Any questions on this part? Nice. Okay. So I guess we can switch over to Satya and then check later on to see if our Elastic Beanstalk has the full.
Okay, great. Okay, so let's kind of try to tie this back to the actual kind of name of the workshop, right? This is called the DevOps and Cloud Workshop, right? So we've been spending a lot of time talking about Docker, but let's try to frame that in like the context of what DevOps is. So before we talk about that, just a quick kind of note on what DevOps is. Has anyone heard the term? Does anyone want to give a definition? Yeah, that's okay. It's not really taught, at least in any of the classes that I've gone to yet. So, but the key thing to recognize is that it's actually just two words being combined. So the two things, as the name somewhat implies, are development and operations. So generally, when people are kind of creating programs, creating software to sell, there's kind of a duality in terms of like they actually have to develop the software, and then they need to kind of find a way to share it with others. So yeah, what do you guys think might be some of the steps that comprise the development part? If you're developing an application, what do you have to do? Yeah, so some of the common things you'll probably have to do is like obviously write the code. That's the main one. You probably want to build the code and have a little bit of testing going on. But most of that stuff happens kind of behind the scenes, like internally, right? In terms of operations, generally folks will need to find some way to actually deploy that application and then maybe get some feedback on it and see how they can revise the application for future kind of releases. Okay, so yeah, we've defined these two terms, but why would anyone really want to combine them into like one kind of DevOps process? Any ideas behind that? Right, because it seems like a lot of work, right? I don't want. Presumably, one person is going to have to do this whole process if we combine like, development and operations. And if somebody has all that responsibility, they're probably going to make a mistake. But yeah, so the reason why we actually choose to combine them is because if you look at the process and see where people generally make mistakes and where most of the errors start showing up, it's going to be right in the middle. When somebody is actually kind of trying to deploy an app, maybe they need to figure something, or when somebody's trying to like propose a change, the users and the developers don't really have like a clear line of communication. So the actual process, like we waste a lot of time developing something that we don't actually need. So again, then I have CI/CD here. This is just another kind of name for DevOps. It just stands for continuous integration, continuous delivery. Okay. And then here's kind of a filled-in version that we're going to be using as we kind of talk about containerization and the other tools that we're going to be using. Okay, so just to really hammer this home, let's just go through an example of creating a game with this kind of DevOps framework. So generally, the first step is planning. So that would be maybe like coming up with some concept art, that kind of thing, deciding on the genre of the game. And then after that, obviously, you want to kind of start coding something so that you actually have something to show off. And then after you've coded something, you want to build it so you have something that can actually run. but generally you don't sell this executable file directly to customers. They could just use it and modify it on their own. So after that, you're probably going to want to test it just to make sure everything looks good. Sometimes you'll have to go back to the coding stage. But if everything looks good, then you kind of get into the operation step where you have to worry about releasing it. So like in the case of like a Nintendo game, you'd probably sell it on like a digital shop, or maybe you have a physical copy. And then after you've deployed it, you want people to actually use it so that you can get some feedback, and then maybe do some patches if there's some issues. Okay, makes sense, everyone? DevOps. All right, great. So now let's kind of talk about another kind of a tool that's used as part of this development operations process. So like I mentioned, right, it's a lot of responsibility for one person to have. So it's really important that we have some efficient tools to kind of streamline this process. And a lot of that is just about automating the process as much as possible so that we can minimize human error. So for example, with version control, one of the reasons why we have this is just to kind of automate the process of people developing in parallel and not having to worry about them like overriding each other's changes. Does anyone have any other thoughts as to why versioning might be a good idea or the advantages of using this? All right, no worries there. So before we get into that, we can think about most versioning is actually what's known as centralized versioning, meaning obviously there's one kind of, I guess, single source of truth that when people make changes, they all kind of go to the same place. So if somebody wants to read the current version, they can get it from that single source of truth. So the reason why this is so great is because obviously it allows for collaboration, but it also allows you to share your code with others, get feedback so that you can actually make changes that are necessary, and it allows for iterative development. So all that really means that we expect to make changes as we develop. So we're kind of planning for that ahead of time by allowing us to kind of version differently, split off, make changes, and then kind of merge them back in. Okay. So a common versioning control tool is GitHub, which is built on Git. And some of the main features there are just branching and merging, like I mentioned, which allows for parallel development. Okay, so before we move on, let's just think we're on this diagram. I know it's kind of small, but where do you think versioning kind of fits into the DevOps paradigm? Yeah, so the key here is that it's going to be somewhere around there. You're more than likely going to have a single kind of branch that's just your release branch. Maybe you have a couple different releases, versions. So to fit in right in the middle, kind of intersecting with the test, coding, and possibly the planning stages as well, depending on the versioning tool. Okay, great. So, yeah, any questions? Okay, awesome. So now we're going to talk about another tool that's a little bit more kind of specific to AWS, but all cloud providers have a version of this called AWS Code Build. So as the name implies, this just helps you build your app. That's great, right? But why is this useful? Like generally, when somebody's developing that code, they can just build it locally, right? To play test it or whatever, right? So why do we need like a specific service in the cloud to help us build our app? Well, the reason why is because it facilitates testing. Not only does this allow us to run in an environment that is the same as the environment that we intend to actually deploy our app in, but it also allows us to kind of build in automatic tests so that all we need to do is press a button to build it, and then it'll build, make sure everything's okay with the configuration, and then kind of run those tests, make sure everything is actually working the way it's supposed to. So yeah, again, just getting back to the idea of automating as much as possible to minimize the chance for error. So code build can pull our code from a variety of sources, S3, like we talked about, where that went, GitHub, among others. Oh, shit. Oh, whoops. So where in the diagram, pretend you didn't see that, would code build fit? Yeah, so it's not a trick question, right? It fits into the build section. And I would also argue the testing section, right? Because the main point behind this is to actually test our code. Okay. So now we can get on to another AWS service. This will be the last one that we use to kind of connect all these things together. So obviously we have a way to do the build. We have a way to kind of manage the versions. And then we have a way to actually deploy that. We're going to end up using Elastic Beanstalk again. And we'll talk about that in a second. But wouldn't it be great if there was a way to kind of connect all of them together so that we don't need, all we need to do is press one button and then it automatically do everything for us? Well, fortunately for us, there is a way to do it. And that's with AWS Code Pipeline. So Code Pipeline kind of takes a step back and just allows you to connect a variety of different AWS services together in series. So the idea behind this is we would kind of say, hey, once you have a repository and press a button, feed it into code build so you can be able to do your tests. And then once that's been approved, just feed that into some sort of deployment service so that you can actually share with it. So some of the great things about Code Pipeline is that it allows you to do quality control in that you can have like steps where you basically need some sort of manual review. And then you can also look at previous versions, revert to previous versions, that kind of thing very easily. And it allows for like fast, kind of streamlined deployment because all you need to do is press one button. Okay, so in terms of the diagram, we're going to see that this fits in right over there. It's a tool that's mainly used for connecting your build to the actual deployment. I guess it could theoretically encompass the entire DevOps scope if you think so. But yeah, any questions on these tools that we talked about? Okay, great. So yeah, now we're going to quickly return to Elastic Beanstalk. This is the tool that we're going to use to do the deployment. So just like what we saw with Docker, we can run, like if we have some code that's containerized or built in some sort of way, we can run it using Elastic Beanstalk by just saying, hey, here's my build, run it. So yeah, I'm not going to go through all of this because Nathan went through most of the main topics. But the key things with Elastic Beanstalk is that because it's this platform as a service model, it's not like you don't have full control of the hardware. They'll actually do the scaling for you automatically. And then they'll do what's known as load balancing that we talked about between your different kind of instances that it allocates. Some of the disadvantages of using Elastic Beanstalk are that you are limited to the frameworks that they have, meaning like I can use Node, I can use like a Flask or something. But if I wanted to use something a little more obscure, maybe Elastic Beanstalk won't support that. So then I would have to do use something a little bit more hands-on, maybe like EC2. Okay. So we went through a lot. Oh, okay. Yeah, like you probably could guess, Elastic Beanstalk fits into this right side there, the operation section, because all it is it's just a tool used to deploy like something that's already good. Okay, great. So we went through a couple of different services there. Any questions on the purpose of any of those? All right, so before we move on to the demo, actually, I'm going to take a quick second to just go back to the idea of Docker and think about where on this diagram Docker fits in. So what we'll note is that Docker actually more or less encompasses this whole process because we write code, we can build it, we can test it, we can release it in some form, like we push it out to Docker Hub, and then other people can easily pull it. Obviously, it's kind of a development tool. It's not intended for like users to just kind of click a couple buttons in the browser and see it, but it kind of encompasses that whole DevOps process, which is a great thing about Docker, and one of the reasons why it's so popular. Okay, so with that out of the way, let's get into our last demo here, which will be about kind of creating that streamlined process with AWS. So what this will look like here, or our actual demo, which we have everything working, is that we will have a GitHub repository, so our own kind of app code, and then we're going to try to feed that into a pipeline so that when we make a change to our repository, it'll automatically build that and then put it to the live site. So to do that, we're going to have to use AWS Code Pipeline to create our pipeline, like our steps. And then all we're going to do is say, okay, so connect the repository to code build, which will build up our code. and do some checks. And then we're going to skip past this, and we're just going to say deploy. If we wanted to, we could have added a manual approval step here, meaning we would build it, and then we would need to give it the green light, and then it would deploy it, which in real life you'd probably want to do. But in our case, we're just going to cut out that middle step and have it automatically deploy it to the live version if we make a change. So the idea here is that I'm going to type something, type in like a message, save my GitHub repository, push it to a GitHub repo, and then once I push it, in a couple of minutes, we'll see it on our live deployed site. Okay, any questions there? Okay, great. So yeah, some of the prerequisites you'll need are Node.js to run your app, something to write your app into VS Code, an AWS account, obviously, then a GitHub account to deploy, commit your changes. Okay, so I'm going to kind of hand wave some of this here, namely the setting up permissions, because that stuff is more or less just following directions. So to do that, for this process, you're going to have to create like an IAM role that we've actually done before. And the directions are in the slides here. It's not very many steps, just like I guess 6 steps here, but I'm kind of stretching it out. But once you've done that, we are going to get into the meat here. Actually, we'll come back to this at the end. Nathan's little demo here. It looks like it's working, so that's great to see. But yeah, for us, we're going to start by creating another Elastic Beanstalk environment. So we're going to want to go with the web server. We can give it a name, HackCloud demo, I guess. Very creative there. And then we want to scroll down and under platform. In this case, we're going to choose Node, not that, we're going to choose Node.js. And then we can scroll down again. And in our case, we can leave this application code as sample application. We're going to plan to replace this with the actual GitHub repository that we have. And I'll talk about that in a second. But for now, we can leave it as sample. And then we can just click next here. Again, for the roles, we have to give it basically this first role here, the service role, is the role that when it's trying to create the underlying hardware that it's going to use, these are the permissions that it has. So we can actually click create a new service role, and AWS will create a new role that has like the permissions we more than likely want. In my case, I've already done that. So as you'll see, it has the same name. So if you're doing this for the first time, click create new service role. And then here we can, we don't intend to connect to our actual EC2 instances, so we can leave that empty. But we do need to give it an EC2 instance profile. So these are the permissions that the actual kind of computers that are running our app, these are the permissions that they will have. So this first one is about permissions to create those computers that will run our app. This one here is about the permissions that our computers will actually have. And this is the one that we do in steps 1 through 6 that I kind of hand waved. Once you have those, you can click next. You could also just click skip to review because we're going to be skipping the rest of the steps. And then we want to scroll down and click submit at the bottom. Okay, so now this will provision our environment. And again, we'll take a couple minutes. So in the meantime, let's head back here and talk about what our repo looks like. So to do that, you're going to basically want to just click on this link, which is a AWS provided kind of free demo that they have. And then you're going to want to fork that repository. And then you want to, after you fork it, back to your local kind of your account, I guess if it's not local, you want to clone it locally. So that's just the process of copying that code so you have it on your actual computer. So I've already done that just to kind of speed things up. So here we have the code, but I haven't made any changes yet. So the first thing we'll want to do is change this app.js file slightly. So I'm going to copy what we have on the slides and paste it in. The actual changes that you'll note here are this line here. I've changed to either reference the port 8080 or use like a kind of environment port if it's present. And then I've changed this message here to say hello HackCloud. That's all. So nothing too tricky. And then the next thing we're going to want to do is click over to the package.json file and remove this line here, main app.js. Okay, so once we've done that, we want to save these two files and then commit the change to our repository. So just as a reminder of how that works, we can do git. Oh, dear God. I'm going to create a new terminal first. We can do git add star. This will just add all our changes, and then git commit -m for our message, then type it in. So cool commit, and then git push to push our changes to like the remote repository. All right, great. So that those changes have been made and saved. So now we can, before we move to the next step, we're going to quickly head back here. Refresh this. Okay, still going. Any questions on what we've done so far? Okay, great. So yeah, now we have a repository. We have a place like eventually that's going to run our code, but we need to kind of create that pipeline, right? So to do that, the first step would be to do the code building step, so that we have something to feed our repository into to build. So to do that, we're going to head over to code build. That can be found under developer tools and then code builder. And we're just going to click create build project. So we will give it a name. I'll just go with HackCloud build. And then for source, we're going to want to pull our code from GitHub. So to do that, we just click and select GitHub. And then we're going to have to click connect to GitHub. So this is going to basically make me log into my own GitHub account so that it can pull the repository that I have. So I'm going to click authorize and then type in my password that I totally remember. And then I'm just going to click confirm. All right, great. So once this loads, it's going to let me, it's going to have like a drop down here and let me choose. Oh, sorry. First, I need to select repository in my GitHub account because obviously I want it to be one of my repositories. And then here is where I choose the one that I want, which is this one here. Right, this is the AWS sample that I just forked. And then once we're done with that, we can just keep scrolling down. This part is okay. And for the build spec, this is basically the configuration for the actual build. We're going to click insert build commands and click switch to editor. So this just allows us to enter our own build commands. We're going to head back to the slides and copy over the commands that I have here. Just paste them in. All this is saying is just run npm install to do like before you do the build, so that it gets any necessary dependencies. And then we can scroll down and just click create a project. Oh. Okay. Let me change the name slightly. HackCloud build demo. I believe it's the issue has to do with the fact that I've already done this before. Hold on 1 second. Oh, I see. Okay, so part of the issue is that I didn't. Yeah, go ahead.
What's the repository again? Because I wasn't able to get access to the slides.
Oh, it should. The slide should be in the Discord.
It says permission denied.
Oh, okay. Can somebody fix that? Yeah, let me. I think if somebody fixes that, you should be able to get it. Is that okay?
Okay, but what's the repository
again? I can show you what the link is, but once the slides are available, you should be able to just click on it. Hold on 1 second.
I was unable to access the slides. That's why.
Yeah, I think somebody's going to open it up for you in a second. Okay, awesome. Thanks. Yeah, you should be able to access the slides and grab it there. Is that okay?
Okay.
All right. Yeah, sorry about that. Okay, any other questions? So yeah, what I forgot to do here was select the operating system that our build should be working with. We're just going to run it on Amazon Linux 2, which is the default one. And we're going to need to select the runtime, which is just the standard, the only option that we have. And then we're going to select this one here, standard 3.0. I think the other one should work, but this is the one that I've done it before with, so I know it works. And then the service role, hopefully we could just leave it the way it is. The only reason I was running into an issue is because the name conflicted with something I'd already created. Okay, so we will let this run. Awesome. So it's created. And now we're going to click the start build button. So what this is going to do is it's just going to create our actual build. But the build isn't going to do anything, right? So just building our code is just saying, hey, you can actually build this code without any errors. We will let this run and go back to the slides briefly. Okay. And then the next step is we have a way to build our code. We have our code itself, and we have somewhere to actually run our code. Let's connect all three together so that if we make a change to our code, it builds it and then runs. So before I do that, I'm just going to quickly switch back to Elastic Beanstalk and show you what the default kind of standard app looks like. So remember, when we created our Elastic Beanstalk instance, we said run it with the standard like node code. So this is just the default app, right? As you can see, it just says like everything's working. So we're going to replace this with a much more interesting app in a second. So yeah, to begin this process, we're going to want to switch over to code pipeline. So that's again under developer tools right here. And then click create pipeline. And then we want to give it a name. We can go with HackCloud pipe. And then we're okay with this here. So we can click next. And again, for source, we're going to have to do the same thing we did last time. This version 1, version 2 thing, I think this is like kind of legacy based off the ways that they didn't wait to have to kind of connect like login to GitHub. We're just going to go with version 1. And then just again authorize like we did last time. And then click confirm. And then there we go. Again, we click on the same repository as last time. And then this time we have to select a branch. So we're going to go with the main branch. Okay. Then we can click next. And here we actually say, so once we have our code, what should we do with it, right? So we obviously we want to build it. So we just click AWS code build. And then here we want to select the name of the build project that we just created. So this is the one that I just created. Currently I named it with a D at the end, which is fine. And then we just click next. And then this is basically saying, okay, so once we have the build, where do you want me to run this? So here's where we connect in our Elastic Beanstalk, and we just select the environment that we created. So we're going to want to do HackCloud demo, right? Not the one Nathan created. And then this environment name is just saying select. So this is just a template. This is the one that's actually running. So this is where we want to run. And then finally we can review. So we're okay with everything. We can just click create pipeline. And as you can see, once this runs, it's going to actually automatically start the process. There we go. So yeah, you can see this source section says in progress. So it's pulling our GitHub code right now. And then after it does that, it's going to run this build step where it actually tries to build it. And then at the end, it's going to automatically try to deploy it. So if I want to stop it, I can just click the stateful transition. Okay, great. So it looks like this part succeeded, and now it's moving to the build step. So this will take a second or two. So we will let this run. In the meantime, let's quickly check on two things. So the first thing we'll check on is this one is not still running. I will refresh it. Okay, well maybe it is then. Okay, well the build should work. I'm not sure why it's still running. So let's not worry about that for now. We will come back and check on it again. Let's go back and look at the Elastic Beanstalk environment that Nathan created. So again, this is the HackCloud propaganda environment. And if we click this link, you can see this crazy app. Oh, that's so crazy. No, but yeah, that's this was the container that Nathan was just running. And obviously it's working. And if you were to go to this domain, you would see it. So it's very simple to deploy and very highly portable, right? Which is the main thing. Okay. So let's head back to the pipeline. You can see it's still building here. I think the build takes a short while actually. So we will let that run. In the meantime, let me show you what the app should look like. So I can run npm start. here. And once this runs, all that is just, as you can kind of probably guess, it's just going to display hello hack with no static. So okay, if I click this one here, hello hack, right? So this is what we intend our actual kind of EBS, or sorry, Elastic Beanstalk instance to display. And then once that works, we are going to we're going to make a small change to our repository and see that if we make that change and just save it and commit it, it'll automatically start this process again. Okay, it is taking a little longer than I would have liked. Any questions on the process so far, though? Because the key thing is understanding the process. Okay, great. I did have some AWS trivia questions prepared, but it sounds like, well, from what I'm gathering, I mean, it's Thursday, week 6, so I don't know. Are you guys up for the trivia questions? Let's see. It should not be taking more than like, I mean, it only took like 2 minutes or so when I was running it before. Let's see. Okay, so this, I think the issue may have been that I was running 2 builds at once. This one here, this was the first one that I ran when I clicked this like start build button. We can already see it succeeded, right? No issues. Hopefully the second one works out. I guess in the meantime, oh, I also have this thing. So on this slide here, feedback form, obviously, great to fill that out if you are just kind of waiting to tell a little bit of time. Also, these are all, 3 of them are AWS services. One of them is not. I will give out a couple of candy. Somebody that can tell you when it's not real. It's not too tricky. I mean, I was kind of sloppy, honestly, but 25% chance of getting free stuff. Oh my God. Okay, don't look it up. Oh, unfortunately, that one is real, but I have to do
They're all in the green color, in the same color. They're all green.
They all agree here. Yes.
I have a 33% chance of getting it.
That probability class is paying off, dude. Which one is? Which? Oh, okay. Nice. Which one is the top right? What is this? That's what. Oh, okay. I mean, honestly, I don't know what the hell they were thinking. But this is the fake one here, right? As you can see, this part, all I did was just copy this part, paste it one more time, make it a little smaller. Right. So I just like remove this back rectangle, paste it in the front part. This is the thing. But yeah, here, let's give you some time. All right, but it looks like the build's finished. And it's onto the deployment stage here. So if we keep refreshing this, there we go. Yep. So it's been replaced with our version. So now the last part of this demo is actually kind of committing a change and making sure that the pipeline actually automatically goes through. So to do that, we're just going to say, change this to goodbye, save it, and then we're going to have to commit this change. So I'm going to do git add app.js to add this file, and then git commit -m message 2. Very creative there. And then once this has been committed, we can push it. So git push. Okay, it's been pushed. let's go back to our pipeline. And we can see it's already pulling the source, right? I didn't press any buttons or anything. It's just automatically seeing, hey, there's no changes. So let me pull it. So once this is done, again, it'll go through this process. I don't know why deploy said, oh, there we go. Okay. I think it's just a little slow, but everything has been. So now it's doing the build. And once that's done, it should do the actual deploy. So let's give that a second. The other kind of questionnaire thing that I had in the slides, let me see if I can find it. Where is it? This one here. What console is this game from? And what game is it also? It's kind of small. Like, don't look it up also. My God. Yep, good.
Is it the Game Boy? I'm not sure.
Yeah, not quite. Not quite. It is a Nintendo game though. That's not a bad guess though. Yeah, it is it's Mario Bros. That's Mario there.
I saw you were asking about the console.
Yeah, I was asking about the console, but it is a Mario game. Oh, let us see. So, yep, still building. So remember when I authenticated, right? That kind of gives it the same permissions as if I was to log into my own GitHub. So I'm not actually sure if it's like polling it or if it's like event driven or something. That would be good to look into. But it's one of those two. It's either a kind of periodically polling the repository, which that's probably not the way it's doing it. It's probably actually just listening to see when there's a commit, and then just go after that. Does that answer your question? Yep. Okay, build is done, deploy is done. Let us refresh, and we can see it says people are hacked. Okay, so kind of drag that part out, but we will. That's more or less all we have. Let me quickly finish up by just saying, if you're looking to kind of build upon this process, I would recommend looking into adding that manual review step, and then also thinking about if you were to add different branches, how that would work. And then there's also this kind of notion of having multiple deployment versions, where like one of them is that kind of experimental version where like you route 20% of your traffic or something. And the other one is the main version that's pretty standard. That way you can like test out new features without having to give it to everyone. So those are all things that you could look into with this process. So yeah, we will end with the feedback form here. Our next workshop is an hour earlier again, because we don't have this time. So 6:30 to 7:30, but it's in the same room a week from today, and we will be covering machine learning in the context of that. And we should have food, right? Okay, so yeah, once you filled out the feedback form, I'm going to emphasize this, then go get the food. But yeah, thank you all for coming, and hopefully you have a great rest of your night, your week. All right.